Let me give you coffee drinkers a bit of a warning. If you're contemplating going down this long, dark road of espresso, proceed with extreme caution.
Hi, hello, and welcome to Coffee Literature Review. I'm Chris Hendon, and as ever, I'm joined by Doran Pennington. Today, we're discussing an interesting paper that attempts to see if the human can beat the machine in brewing filter coffee. The paper was published in the Journal of Food Composition and Analysis in 2023. Its title is The Impact of the Human Factor on the Reproducibility of Different Coffee Brewing Methods. So I'm joined today by Masha Zanozina. Hello, Masha.
Hello.
We're really lucky to be able to meet with you. You're the first guest that we've actually met with prior to recording.
Oh, wow.
Yeah.
Since the birth of the podcast.
Well, I hope I'm not the last guest who you meet before recording.
Masha, you have a decorated career in specialty coffee. You're an AST, which is an authorized SCA trainer, also a U.S. Brewers Cup judge, and also are now working at Counterculture Coffee in Los Angeles in their training center.
I'm not only U.S. Brewers Cup judge now, I'm also a World Brewers Cup judge as of last week.
Congratulations.
At the national competition, I'm actually a head judge now, and a part of United States Brewers Cup committee as well. So kind of like on a organizational side of things.
Well, so let's talk briefly about the Brewers Cup. Most people who listen to this podcast probably are familiar with the format of the Brewers Cup. However, we're trying to diversify into the scientific audience as well, and some will be less familiar. So with that in mind, can you elaborate or can you explain how the Brewers Cup is structured? There's, I guess, two types of drinks that must be presented, and how you assess these drinks.
Yes, for sure. That's a great question. I have to explain it a lot. Competitor has to brew 3 individual brews during one performance. And there are 2 components of the competition, or 2 different presentations. Let's say one is open service, when you brew coffee for the judges, for 3 sensory judges, and there will be 1 head judge.
And those coffees are typically high-end, beautiful, elegant coffees that are, pushing the upper limit of what coffee excellence is in specialty coffee usually, right?
For sure. Everyone tries to bring the most unique coffee. Again, we have to remember here that this is not a cup of excellence. This is not a coffee grading competition, right? This is a brewing competition. So you have to remember that. We as judges also have to remember that. What is competitor doing with it? How do they brew it? How do they explain it? What they do? How do they walk us with it through experience of sensory experience with the coffee? Basically, it has to be we're thinking about it as that experience should be close to a real cafe experience, right? Basically, when you're going to the coffee shop and buying pour over, one of the pour overs, and barista is brewing it for you and walking you through the sensory experience, right?
Let me make a micro complaint about the Brewers Cup with the open service round in particular. Until recently, you were also able, as an audience member, to taste the same coffees that were being presented to the judges at the brew bar that was located typically right behind the stage of the Brewers Cup. So you'd be able to share that sensory experience. And I know that, of course, some of these coffees that people are serving are very, very expensive. And so the burden of asking a competitor not only to present it to 3 judges, but also to serve it to the general public was beyond the capabilities of some coffees and some people that are competing. I think we should bring that back, and we need to figure out how to pay for it. The best thing that the Brewers Cup had was the fact the audience could get involved and taste these coffees that you were tasting and understand like what scored high.
Yeah, can I add something for what you were talking about is called audience service, right? And that was mandatory before 2020.
Yeah, COVID killed everything.
At the national level of the competition, that was an option for competitors. Usually competitors, they're willing to showcase their coffees because they really want to they really want to share with everyone and more than 3 people, because those coffees which they bring, they're usually some beautiful story of connection with the farmer, with the producer. Of course, they want to share with everyone. So I think it's going to come back.
Okay, well, so that's good to know. For the prospective competitors listening to this podcast, I'd strongly encourage you to do this, because this is, if you can afford it, this is truly an outstanding facet of the Brewers Cup that is not reflected in the Barista Championship. In fact, my parents flew to Dublin because they knew that it was going to be so fun that they just hung out at the brew bar and talked to every competitor and tasted all their coffee. This is my parents. Anyway, okay, but you know what they don't want to taste necessarily is the other part of the Brewers Cup Championship, which is where a competitor is given a compulsory coffee. Typically, one of the sponsors of the event will have a coffee they roast up. It's the same for everybody. It's a specialty coffee. Typically, you can tell me if I'm wrong, but typically it is not going to be a 90+ point coffee. It's going to be a good example of a solid specialty coffee, and you got to do your best with it. So this is called the compulsory round. Tell us about the compulsory round and how it's unique and what you glean from it.
Every competitor is using different brewing device. Usually they bring their own brewing device. There can be different paper filter. Obviously, they're gonna do a different pour structure. Every competitor is using different recipe. And yes, there are variations in the brew.
I've seen people mess it up before. I've seen people get disqualified in the compulsory round.
Disqualification usually happens if, I think the main thing is that split beverage. You brew one big brew and you split it between 3 judges. No, you have to brew 3 different extractions.
And to that point, so to the point of reading, and then the point of reproducibility in multiple brews, we've been charged with the task of discussing the paper published in the Journal of Food Composition and Analysis. And the article title is "The Impact of the Human Factor on the Reproducibility of Different Coffee Brewing Methods." What this paper, in essence, is basically trying to understand is how variable is each barista when they go to brew following the exact same recipe. So if I said to you, you're going to pour X amount of water on at time point 1 and X amount of water on time point 2, you're using this amount of coffee and this amount of total water at this temperature, do you get the same chemical composition out every single time if you follow the same brew recipe? But I do want to say that from time to time in the coffee science literature, you'll occasionally come across articles where they are seemingly heavily motivated by an industrial problem. And more often than not, there's also some funding that has been provided by an industrial partner, because of course the funding is necessary for research. And just because a company has funded research does not mean that the research is biased. Money has to come from somewhere. Companies are the places that have money. This paper is no different to that, in the sense that there is obviously a business interest in this, and that one of the brew methods is a new brew method. And what is not disclosed in this paper is that they are all affiliated with Nova Simonelli, the producer of the so-called pure brew method. Instead, they have affiliations of the Research and Innovation Coffee Hub, which also is geographically located at Nova Simonelli. Now, that does not necessarily mean that this is a biased paper, nor is it necessarily an advertisement for that product. But I do want to say then that it should be disclosed that indeed this paper was heavily influenced and came to exist because the people that are working on it are also working with Simonelli. One could ask the question that if the findings of the paper we're about to discuss were very negative towards this development of this pure brew device, would the paper have been published? And I'm not saying one way or another, because the data within the paper is good. And so the data does deserve to be published independent of the discussion. What we're here to do is not criticize that, but just point out that the data, more often than not, in these papers that are funded by industry and have seemingly relatively transparent relationship between the people who funded it and the outcome of the paper, don't necessarily mean that the experiment was biased.
Right. So this paper is really about inter-barista variability. So there are 4 brew methods: pure brew, which is a newer brew method, and I'll let you guys talk about what specifically that is, as well as more traditional brew methods: V60, AeroPress, and French press. And 6 different baristas were tasked with brewing coffees by each of these 4 different brew methods. They were all given within a brew method the exact same grind size, the same recipe to follow, and they were just said, make this coffee. And upon making the coffee, the variability between each of those 6 different baristas across the 4 different brew methods was measured by a few different means, by chemical analysis, by things that are industry standard like TDS, brew time, etc. So they're looking at, if you tell 6 different people to make coffee, how different of a coffee do they prepare?
So, Masha, what is your expectation going into this? Give us the hypothesis. If you had 6 different baristas and you were told to brew coffee using 15 grams of coffee and 290 milliliters of water, which is the brew ratio they use for all these systems here, would you expect the cup to taste the same?
No, I don't expect cup to taste the same, but also I don't expect every single coffee consumer to taste a difference. It's not going to taste the same for me, especially if those cups will be placed next to each other. But if I drink that coffee today and then tomorrow, when you drink it individually, I don't think you can taste that kind of difference. So I don't see generally, I don't see the slight variability in the brew as a problem.
Yeah. And so that kind of gets to the point. Let's pick a brew method. Okay. Let's pick the V60, something that most people would be familiar with. We can look at some of the data here. The target of the V60 is to pour 290 milliliters of water on this 15-gram bed of coffee. And you're going to want to stop at some volume. And then the next thing is you're going to want to make sure that you're pouring it so that the end of the drips of coffee hitting the cup hit it around the same time. So in other words, brew time is more or less the same. And if we look at the V60 brew times, what jumps out at you is that the fastest brew took 2 minutes and 9 seconds, and the slowest brew took 2 minutes and 45 seconds.
Mm-hmm.
I'd say that that's about it's about 35-second difference, half a minute, let's say. And in your experience, if on the competitor stage, for example, let's say you're in the open service round, if one cup drew down 30 seconds slower than another, would you expect a pretty sizable difference in quality?
Oh, it's gonna be a huge difference for sure on the competition side, 100%. Like, when I do head judging for open service, my main job is to look at the uniformity of 3 brews. So I actually look at the speed of every pour and I record how long is each pour and how much time is between each pour. So I do have all that data, and tech information never lies. It's really cool to see how my recordings, when we deliberate with my sensory judges in the end, and I'm seeing that they're giving different scores and giving different descriptions, and I look at my recordings of technical uniformity and it matches.
So this is an interesting point because the variability that you're describing is actually a type that is not captured in the paper, which is if you ask one person to make a V60 3 times, that is an intra-subject variability that's not captured here because they asked each person to make each brew method once.
Right. And then so one of the things that is also included in this paper is that they compare TDS, which is the concentration of solvated coffee material in the cup.
Yeah.
And interestingly, the cup that they brewed in 2 minutes and 9 seconds, the fast V60, had the highest TDS of all the V60s they brewed at 1.35% TDS, 1.35. And the cup that brewed the slowest had somewhere in the middle of the road at 1.26% TDS. So all of this is to say that you got different times and different concentrations, but the volumes of water they poured on were pretty consistent. So those 2 cups were only different by 3 milliliters, which is 3 milliliters is not a lot. That's not a big variation.
Not a big variation. Also, I don't think that, 1.26 and 1.3. Yeah, there's variation, but it's not super huge. I guess the difference there was that there was probably like the speed of pouring was different, right? And maybe the gap between pulses was slightly different. That's why it was longer.
Masha, after having read this paper and having a look at sort of the geometry of the picture of the pure brew, which is this From seeing it on the trade show floor, it appears to be an espresso portafilter basket that is conical, made of stainless steel, and you load it up, but you don't tamp it. So you put in ground coffee in there, and then you're going to set your espresso machine to a relatively low pressure, and you're just going to use the shower screen in the espresso machine as the water distributor over this very small conical shaped pour over device. In principle, it's supposed to make a filter type coffee on an espresso machine. And if you control the amount of coffee that goes in that basket and you push a button and control the amount of water, it should not really be a surprise then that you're going to arrive at a reproducible amount of water in the cup and a relatively low variation in total dissolved solids and all the other coffee variables that we typically talk about, right?
Yeah, for sure. It makes sense.
So you probably have seen these pour over devices that will make single cup pour overs
Yeah.
by a machine.
Pour steady.
Yeah, pour steady is an example of a cup.
Yeah, for sure.
And so when I read this paper, the first thing that went through my mind was, would a fairer comparison not be the pure brew, which is just dosing the water via an espresso boiler, comparing that to a pour steady, where if you're really asking about variation, then you're asking about, can the man, or the human, I should say, beat the machine? Now, with that, that's actually not what this paper is about. Title of the paper, which is the human factor in brewing coffee. And so what you can then see is that the V60, the AeroPress, and the French press all give pretty wildly different TDSs.
Yeah.
In your experience, you're teaching people how to brew coffee at the Counterculture training facility. It is possible to teach someone to hit 1.3% TDS with a French press, as it is possible to hit 1.3% with a V60 with the same amount of coffee. You just have to change some parameters so that the TDS was the same.
For sure. I think what happened with French press there in this paper, I think they just got the grind size incorrectly. I think their grind size was too coarse because it like the TDS is very low. Usually it's not like that. I think they just messed up the grind size. And yes, you can definitely change different variables to increase TDS. There are few things, there's 6, how we call it, 6 essential elements of brewing. If you understand how they work, you can tweak those variables and create more, extract more or less, right?
What are the 6 essentials?
Okay, how about you help me to name all of them?
Well,
You know them. You know
okay,
them.
all right, here we go. Ready?
Here we go.
Water temperature.
Water temperature is a huge one for sure.
Okay, hold on. I'm throwing it to Doran. Here we go.
Grind size.
Right.
Grind size. Yeah, and we can even say like more higher water temperature, higher extraction, right?
Okay, love that.
Grind size, finer grind size, higher extraction. Coarser grind size, lower extraction, right?
Okay.
We can manipulate that.
I'll take the next one. Brew time.
Brew time, yes. Brew time is very often related to our grind size, right?
Indeed.
If we're talking about the brewing method where water is passing through the grounds, because in the full immersion brewing method, grind size will not be related to brew time because we
That's right. It's not a resistor.
Yeah, exactly.
All right, Doran.
Well, I am most familiar with espresso, and so I think of pressure.
Yes, so pressure is actually a form of agitation. So agitation in coffee will be pressure in espresso, or any form of turbulence. You know, when we're doing it's just going to be different for different brew methods. When we're making French press, we stir, right?
Turbulence is allowing you to overcome the diffusional barrier that is dictated by temperature and only temperature. Okay, so let me just check. We got 5 here. So we got brew ratio, water temperature, grind size, brew time, turbulence, pressure, agitation, pour structure.
You should know because you do a lot of studies about it.
Oh, I know what the answer is. I absolutely know what the answer is. Doran, what's the answer?
Water chemistry.
Yay!
Hey, for sure.
Right, good. So we've got the 6. I'm going to cut this together somehow to make this sound educational. This was good. Let me summarize. We got brew ratio, water temperature, grind size, brew time, agitation, and water chemistry. The interested reader could pursue a book on water chemistry if they were compelled, But let me address the other 5. Is that from a scientific perspective, there are really only 2 things that dictate all chemical processes. It's how fast that thing's going to happen, the extent to which it will happen. In other words, the rate and the thermodynamic limit to which that reaction will proceed. Let's then turn it back to this paper and say, what did they actually do? Because what they did is they made a pour over, and they control for some of these things. They make a French press and an AeroPress, 2 of the easiest brew methods, I think, to control for a lot of these parameters, because it's full immersion. So all of the water touches all of the coffee for the entire time. And then the pure brew is a system like an espresso, basically an espresso at low pressure in a conical filter. Doran, when they made the measurements of the chemical composition of these extracts, did they prepare the extracts in any way? Did they dilute them or ensure that TDS was the same? Or
So usually the procedure is you just pull out some volume from the coffee and then filter it and dilute it, and those are all diluted the same. It's typically not the case that you control for TDS, where you make sure that all of your samples are at the same TDS before you do the chemical analysis.
Right. I believe that they did not control for TDS. Now, why that matters is that if you do not control for TDS, but you know that what is making up that solvated mass is molecules or are molecules that you're going to be detecting with headspace, GCMS, or HPLC coupled to mass spec, you are building in implicitly that you're going to see more of certain compounds in higher TDS extracts, or so you'd think. And yet, when you look at the tables in this paper, you don't actually see that the highest concentration extracts have necessarily the highest amounts of each organic compound solvated therein.
Yeah.
Now, that is a real pain in the neck, because what would have been really clean for us to discuss would have been, oh, look, higher TDS, higher everything across the board. Then I could have done the math, and we could have said, oh, if you divide by the TDS, so you get a weighted fraction of the mass, then you would say that cup actually has more chlorogenic acid than, the V60 is higher in chlorogenic acid than the pure brew. And that could explain some of the differences in sensory. But because we have more than one variable fluctuating here, it's actually quite difficult to make a apples to apples comparison, I think, when I look at this data. Masha, tell me.
Seeing this data making me want to taste all these coffees. I want to taste them. And I will tell you, I trust my palate more than I trust numbers, because there's so many, coffee has so many compounds. High TDS doesn't mean it's good, right?
Oh, that's definitely true. Let's focus on an easy molecule for fun, okay? Let's pick the most boring one that all coffee people always don't want to talk about, but I talk about it every time, which is caffeine.
I knew it.
Oh, fine. We can pick neochlorogenic acid if you'd like. I'm fine with neochlorogenic acid.
Talk about it.
Yeah. Oh, well, it doesn't matter. We can pick any of them. It doesn't make any difference. The point is that for the pure brew, you're going to see that caffeine is in high concentration. And if you can compare that to the AeroPress, it's about 30% higher than the AeroPress. But if you then go and look at the differences in TDS for caffeine, it's about 30% higher in TDS than the AeroPress was.
Yeah.
So you might think, oh, it's all linear. No, because if you then go look at gallic acid's mean concentration is the same for all 4 of the brews, with apparently no standard deviation. So that is an eyebrow raiser. We could pick another molecule. You get the point. The point is that it's very difficult to delineate which molecules are changing in population as a function of the parameter space that you've sampled.
Do you know that different compounds extract at a different time in coffee? So it's when we start extracting, when we begin our brew, first ones to extract are going to be oils and acids, and caffeine will be coming in the very end. Did you know
so it turns out it's slow. The rate is slow. So I think if you sample, have you done this experiment actually? If you sample a woefully under extracted cup,
Yeah.
like how much caffeine is in a hyper under extracted cup? I mean, there's still some, right? But it's just not a
I
lot.
think it's less for sure than the over extracted. Yeah.
Yeah, and that's just speaking to the rates of different molecules being solvated. So of course, time, going back to one of the 6 tenets that you told us about, time is one of the bigger variables here that is sort of built into why we're getting differences in TDS. Doran, they did GCMS too. What jumped out at you? Anything in there?
Well, I want to talk, Masha, I'm not sure if you have the paper in front of you, but figure 4 in the paper I think is really cool. So this is a plot of the chemical compositions of the different brew methods by HPLC, which is measuring what's solubilized, and GCMS, which is measuring what evolves from the cup, what goes into the gas phase. And the 2 plots on the left are principal component analysis plots. And basically all you need to know is that they don't necessarily point to a specific thing, but it shows you broadly what is contributing to the differences between different methods. And something that's really interesting is that the PC plot for HPLC, which is showing you what has dissolved into the cup, you can see that on PC1, that x-axis, that Pure Brew and V60 line up basically on top of each other. And then on the other side, AeroPress and French press basically line up on top of each other. Mm-hmm. And they don't do a explanation for why that might be, but what that points out to me is that immersion methods make a certain chemical composition that is dissimilar to that of filtration or percolation methods. Mm-hmm. That's the thing that I take from that data set. And then if you look at the next plot down, the GCMS data, you have AeroPress and Pure Brew, which are very far from each other. And then in the middle, you have V60 and French press on top of each other. And I tried to figure out what that might be pointing to, because principal component analysis is kind of blind. It doesn't tell you what the variable is. But looking at their data, I think that's most closely reflected by the brew time. So the Pure Brew is really fast. And so it makes sense that you're not going to have the same fraction of volatile molecules coming off as you would in a French press or a V60, which is also very different in brew time from the AeroPress.
That's that.
I love it.
Let's try and summarize this paper then, shall we? Because I think we've gone through almost all the data in there. Look, the executive summary is there is organic molecules in coffee. You find ways to extract them. And the 6 parameters that you taught us about today are exactly what they're trying to control for. And this principal component analysis that Doran just discussed with us highlighted that if you fold all of those 6 factors into just one axis and say how similar is brew method A to brew method B in some parameter space, it seems that it sorts them more or less based on things that make sense, like how long did the water touch the coffee? What else? Is it full immersion, or is it a flow through type percolation system?
Yeah, also what kind of filter? I think paper filter also showed, I was looking at some data that both methods which were using paper filter were showing slightly different data. I don't remember which category, but I noted that rather than mesh filter, which is definitely going to let more oils and sediment come through, right?
Oh yeah, sure.
Yeah,
that's right, because they had some rheological measurements in here as well.
That one was really interesting to me, and I wanted to talk about the viscosity data, because if I knew nothing about this paper and you asked me which of these coffees is going to be the most viscous, and then you gave me TDS numbers, I would immediately tell you that the highest TDS coffee would be the most viscous.
Me too.
And that is not the case.
In fact, the least viscous is the V60 with a high degree of variability, and the most viscous is the French press, which is actually, that's not overly surprising because it's got a bunch of stuff floating around in it.
But it did have the lowest TDS by quite a lot.
Indeed.
Wrong grind size, I believe.
Wrong grind size. Yeah. All right. So let me summarize then. So what we discussed today was a paper that attempted to assess the human factor in reproducibility of making various different filter strength cups. And in doing so, they presented a comparison of V60 to French press to AeroPress, and then eventually a mechanized version of this, which they call the Pure Brew. Most of the data points to this idea that each one of these methods is going to give you a relatively different chemical composition based on the parameter space of brew time, stability of temperature, whether there's a little bit of elevated pressure, all the things you talked about, these six tenets. The one thing that fills me with sort of a little bit of joy is that actually it turns out I think the human does a pretty good job. You know, the machine, of course, has lower variability in certain aspects, in the sense that it doesn't have as much difference in the amount of water you add or the TDS that comes out or blah, blah, blah. But the human cups seem to actually allow for pretty good statistical comparison between them, which means that they weren't too variable in the first place. So overall, I'd say it's an interesting paper. If you get the opportunity to do a side-by-side comparison, I'd strongly encourage trying to reproduce the experiment. I did sort of a truncated version of it in the lab earlier today. Masha, do you have any closing thoughts on this?
Yes, I think we as humans do a decent job brewing coffee, you know, and I view that variability is not a problem, to be honest, because coffee changes every day. And if we're thinking about coffee shop environment, right, as barista, want to be able to change and tweak parameters according to my coffee as well. So I think, to me personally, it is easier to change the parameters on a manual brew rather than reprogram my machine every time, you know. But I understand that I'm open to new technology, and I think it's pretty cool. If you already have Nuova Simonelli espresso machine, you can purchase that basket.
So Masha, as someone who is in charge of educating, I'm imagining a very large number of people that make coffee. Do you get excited by the possibility of having a brew method where you know that between each person, they're going to basically do it the same way every time?
It depends what I'm trying to achieve. Yes, consistency, I think, is very important for the coffee shop. And I am excited for that option, right, to have that super consistent brew from person to person. At the same time, I want to be able to tweak parameters of the brew a little bit easier, I guess, if I work with different coffees, if I'm brewing Kenya, Ethiopia, Colombia, in different processes, you know, and every day my coffee changes as well. So I don't know. I think human factor is good, or I want to think that human factor is good, especially judging World Brewers Cup competition, because every single brewer will be telling me that their recipe is the best and what they do with this coffee is gonna bring me the best sensory experience, you know. So it's very fun, like, learning experience for me. So I appreciate the human factor in brewing.
We do too. We also appreciate you as the human who joined us today.
Thank you for inviting me. This is super fun. You know, I'm happy to share the knowledge, and everyone is always welcome to the training center on Friday for some free education.
Is that right?
Yeah, every Friday we have a tasting, like a public tasting of coffee, which is free and open for everyone. And then we do, like, people ask questions, you know, so it's a little kind of educational session for everyone.
So just to clarify, the Counterculture Coffee in LA has a free tasting session where they can find you every Friday?
Yes, not just in LA, but every region where we have training center, which we have.
Is that right?
Yes, it is right.
If I lived near one of those, they would be sick of seeing me and Doran. I guarantee it.
Listen, we have people who come every Friday. They bring their dogs. They just our regulars. It's super cool. It's because we don't have our own shops. This is our only time when we engage with our consumers, you know, and it's my favorite day of the week because it's just really cool.
Thank you very much for taking the time out of your day to talk science with us. We really appreciate it. It's been a lot of fun.